Hi everyone, this is the second video into the electromagnetic wave research, and today we're going to talk about the different types of photons that are out there. Last video we kind of talked about where photons came from the atom, and now we're going to talk about the different photons as in regards to the energy and how things actually work for them. So for the record, all types of photons can be broken down into one of 7 categories, one of 7 types of waves. And the list that you see here, actually this is not from lowest to highest energy. I got that wrong. This is from the highest to the lowest energy. So we start with gamma rays, like the Incredible Hulk. Those are the highest energy photons that you could find. X-rays are a little bit less energy. Ultraviolet or UV rays, those are, once again, high energy photons, but not as high as gamma or X-rays. Then we get into a little section called visible light, and we're going to talk a little bit of visible light in detail. We have infrared or IR, microwaves, and radio waves. And these, once again, have the lowest energy. Here, to put things in perspective a little bit, is how big a wavelength is. So radio waves are about the size of a person. A microwave is about the size of a fingernail or a little bit less. Infrared is for little specks of dust, things like that. Bacteria is about the wavelength of visible light. Ultraviolet light is a little bit smaller in viruses. And then in the X-rays and the gamma rays, that's when you get to atomic level. Okay? So notice here, when it comes to energy, as the wavelength gets bigger, the energy gets lower. And here we also have the frequency. Notice the exponents here. Gamma rays have a frequency in the 10 to 20 hertz region. Radio waves have frequencies in the 10 to the 8 hertz region. So when it comes to energy and frequency, as the frequency gets bigger, the energy gets bigger. And once again, as the wavelength gets bigger, the energy gets smaller. So there's an inverse relationship between wavelength and energy, and there's a direct relationship between frequency and energy. And remember, all these lights here in the vacuum of space travel at the speed of light, which is 3 times 10 to the 8 meters per second. They all go that fast. So we're going to start off by talking about radio waves. Radio waves are the safest for us to be around. You guys are around them all the time, and you have no idea. Think about a radio station, if you would, in North Brunswick. You could probably have access to, 40 or 50 different radio stations. So right now, going through your body, you have 40 to 50 different radio waves, just from the radio stations. There's other things that are also radio waves. So, for example, walkie-talkies. They're actually radio waves. So think about how many radio waves, if you would, are going through your body right now. You have all the security guards here have walkie-talkies. You have people like contractors or the fire department or, cops. They have walkie-talkies. So there's a plethora of radio waves going through you right now. Remote controls as well. They operate in the radio range. Think of this as a short-term communication. So if you're talking about building-wide or township-wide, that's when you're going to use radio waves for things. In fact, did you guys know that there's a reason why your radio stations are named by numbers, if you would? So in town, you have Magic 98.3. Believe it or not, that means that the radio wave for 98.3 is 98.3 megahertz. It's actually the frequency. New Jersey 101.5 is 101.5 megahertz. So all your favorite radio stations, they actually have a meaning behind those numbers, and that's actually the frequency that they operate at. Microwaves are also safe for us to be around. When we talk about microwaves being safe to be around, we're not talking about sticking a someone in a microwave. That is not safe. But microwaves themselves in low dosage is perfectly fine. And you're constantly getting hit by those as well. And those are bigger, long distance communication. So if you guys think about cell phones, the cell phone satellite is above you in space. And if it's not above you in space, then there's probably a tower 20, 30 miles away. You are getting microwaves streamed to your pocket or to your backpack or wherever you have your cell phone, and you're perfectly fine. TVs operate the same way, especially the wireless ones. They operate the same way. Satellite radio, once again, the waves are coming from space. So they have to travel a great distance. In fact, some of these things are worldwide. It's like satellite radio, you can access it anywhere across the world because of the system of satellites they have in place. GPS on the same thing, data on your phones, same thing. Bigger communication, if you would. Not just cooking food. So infrared, or IR, is often associated with heat. So whenever you see heat imaging or thermal imaging for your violent video games and you see the thermal scope, it's actually measuring the heat because that heat is oftentimes related to photons. Some of the heat imaging that you guys see have temperature scales. So for example, here, this one actually has a unit, Celsius, here. So here, this color is about 30 Celsius, which is about 100 degrees Fahrenheit. And here, 5 degrees Celsius is really close to freezing temperatures. So here, you can clearly see that there's a bear, okay? Notice the mouth is open, and the eyeballs, that's where they have no fur. So you're going to pick that up on an infrared camera with a lot of heat. And the areas where they have heavy fur, it looks really cold because obviously, once again, the heat is not getting through. The photons are not being emitted over there. Here we have a hair dryer. You guys may notice the handle area, the plug, and the back is relatively cold, but the tip is relatively hot. So if you guys use a hair dryer at all, and ladies, I'm going to focus on you for a moment, you guys know that the tip of the hair dryer can be really hot. So you don't want to actually touch your hair with the hair dryer because you could burn yourself. And then you may notice the effect of the actual air getting heated as it comes out. Here's another picture. Notice this hot guy right here. I'm just joking, I'm not really hot, but actually I am, you could tell. That's actually a picture of me from the Museum of Science in Boston. Notice where my skin is where you see the brightest color. So that's where I'm the hottest, if you would. You could see my glasses have a special coating on them. And the photons for heat are not really going through my glasses. You could see my hair also is insulating my body. A lot of photons for infrared are not going through my hair. And then you could also see my sweatshirt here. Yes, my sweatshirt is lit up because my body heat is warming up my sweatshirt. I'm not warming up the floor around me. Here's another example. This outlet looks perfectly fine, but if you felt it, it may be hot to the touch because of the wiring behind it. So this can potentially start a fire. Here, they use it in medical research. So if a doctor does a scan on you and they find a particular region of your body is significantly cooler than the other parts and it makes no sense, that may give them information to go look in there a little bit more. So this is exactly what happened here. They wanted to look into this because of that dark spot. And then here, this guy is kind of peeing on a wall, and you can see the temperature of the pee coming out and hitting the wall. Just to show you guys, because I figured you would want to see that. Visible light is only 1% of the photons we can see. Okay? Once again, you have radio waves, microwaves, there's a plethora of them, but when it comes to seeing photons, we can only see 1% of the photons they are. And when you talk about color, it's actually a matter of photons. So here's a little table, if you would. Red color is a photon that has a wavelength about 700 to 635 nanometers. Orange is about 635 to 590 nanometers. So any color that you ever see in existence falls within some sort of region here. Black being an absence of light, white being a mixture of a few different photons of light. So that's actually how the colors work. So with that being said, when you look at the frequencies and wavelengths, red is low energy color and purple violet is actually high energy color. That's why it's called infrared. It's before red. And that's where this one comes from, ultraviolet. It's after violet. And once you get to the ultraviolet light, that's where you guys can actually start damaging your bodies, aka sunburns. Okay? You guys probably see on the news all the time with the UV index when you watch the weather. That's to show you how strong those photons are of the UV light that are getting to. They could also be used to sterilize equipment and help you dry nails after a manicure. There's a reason why, ladies, when you put your hand into this device, it actually burns for a moment, because it's actually burning away the alcohol that they use in the nail polish or whatever other kind of solvent they use in the nail polish. They've actually recently discovered that some ladies have been developing cancer in the skin around their fingertips, and they're associating it with these UV kind of dryers. If you have a fish tank, you could also use a UV light sterilizer for the fish tank. Those are pretty common too. Here's some more examples of UV lights. A UV light cannot actually be seen. So when you guys see the glow in the dark effect, it's really the photon giving off just a little bit of energy first and then making their big jump to the bottom lower energy level. If you guys looked at $1 bills under a UV light, you would see these colored streaks through. And every denomination has a different color in a different location. This right here is actually a Canadian passport. So on the left-hand side here is what it looks like normally, but when you go to the airport and they scan your passport under the UV light, this is what it looks like. Notice they have the cool effect here with the dates and the years. They have the fireworks going on. This is just one of the many examples of really cool UV lights. Obviously, LeBron James is not from New Jersey, but if you saw any UV light at a bar or at, as I said, the airport or something like that, it would actually glow with the state of New Jersey with the word New Jersey on them. X-rays are more damaging to people than UV rays. Once again, they have more energy. In this case, we can examine stresses and defects to small things. In this case here, this is actually an X-ray of a dog being pregnant. And you could actually see all the different skulls and basically baby puppies developing. When I look at this, I see 1 skull, 2 skulls, 3 skulls, 4, 5. There's about 7 different puppies in this dog right here that are being formed. And you can tell by the spines too. Here, this is what the TSA does when you put your bag into the screening. This is actually a false color one, so the computer will put color into this based upon the photons that are received so that you understand what's like a zipper, like here is clearly a zipper, and what is something else. Here's another example of an X-ray, if you would. This is actually an X-ray of someone swallowing. It's very creepy, I know, right? Once again, you could see the body is well defined. Through the skin, X-rays go through differently than they do the bones. That has to do with refraction. So you could see when this person here is drinking the black liquid is absorbing a lot of the X-rays, which is why it appears black. And the areas where it appears light is when the X-rays are passing through. So that is why you can get skin cancer from X-rays, but you don't generally get bone cancer from that. Here, this is actually my X-ray from about 8 years ago. You could see I had a cavity. That's my nose. That's where the nasal passage is. And right here is actually where I broke my first tooth on a gummy bear. And if you guys want, I'll tell you that story. It's a very interesting story. But yes, you could see how this looks a little weird compared to all the other teeth here. That's because I broke my tooth there. And lastly, gamma rays are the most deadly waves. They are rarely naturally occurring. They really only occur in the star or in the sun. Photons in Earth can't get up to this energy level. So they're only really produced in nuclear bombs, things like that. Here's basically what all we use it for now is just to kill things. We use it to kill cancer. We use it to sterilize things. So chemotherapy and radiation use gamma rays.